This is another video. This is G12 2023 paper 2 GCE, the paper that was written last year. So this was question 2a. The question reads, in a geometric progression, the second term is 21 and the fourth term is 189. Calculate the first term and the common ratio. Number 2, the 60th term. Number 3, sum of the first 5 terms of the progression. So this is the question that we have. So here we go with the solutions. So when you are faced with this question, you first need to collect your data. So we have Tn equals, this is a geometric progression, so we're going to have this formula. So just an illustration, for any term that you are going to have, maybe term number 7, it's equal to a r power 7 minus 1, which is equal to a r power 6. So from this, we can note that if the term is on 7th, the power of r will be less by 1. So suppose the term is on 100, we expect to have 99 there. So that is the idea. So in our case, we have been given from the question there, they are saying the second term is 21 and the fourth term is 89. So T2 equals AR. So this 2, the power of R should be less by 1. So this is what we have been given, and we have been told that it is 21. Then we have been told that just from here, T4 equals AR3. So my emphasis is that when the term is number 3, you expect your R to have a power which is less by 1 to the term which you have found. So that is my emphasis here. So make sure if term is number 6, you expect to have AR power 5. So these should always differ by a 1. So this will always stand, and it is very true. So you'll never go wrong by doing like that. If it's term 10, you're going to expect R power 9, just like that. So this one is standard as a formula also. Okay, so from our question, we have been told that term number 4, which we are referring to like this, it has been told to be 189. So this is our term number 4. So now let's take, for instance, this is A times R giving you 21. Then A, R is the one giving you 189. We know that these are multiplying. So if you compare the two expressions, you can see that this part can be put here. So that is how this can be done. So A times R can be replaced in this one, which is A R to the power equals to 189. So if that can be done, then we know that this A times R is 21. So we can replace a 21 here. Upon replacing 21, we are getting rid of A. So in simple terms, we are talking about 21 after being replaced here. We are remaining with R, which is R squared equals 189. So from here, we are looking for R. So we are going to divide 21 from both sides. And we are expected to have that. This one will divide off, leaving us with R squared. Then from here we can try, this is 9, then 2 times 9, it's 18, which is giving us 1. So in this case we're going to write that 21 can go into 189, 9 times. Then if you check your progression, the second term is 21 and the fourth term is 189, meaning they are moving in a positive way. So even after finding the square root, we are just going to rely on the positive value of r because the progression is in a positive way. So that is how we can find r. So I'll just go through the data. This is the formula, but we can simplify to say if your term is number 2, r should be less by 1 to its power. Just like if a term is number 4, it will be the power of r will be less by 1. Then we were told that this second term is 21 and this fourth term is 189. Then we came up with this idea of saying AR can be written like A times R, which is giving us 21. Then A r power 3 can be scattered like this, which is A r r r. Then we have seen that this guy can be accommodated into this one. So who is this guy? This guy is a 21. That's how we came down here and replaced on this part. We replaced with 21 and what remained is r, which is r squared. But this guy was equal to 189. Hence we put 189 there. Then we have noticed that we've just remained with r. So that's how come we have divided 21 from both sides. So after dividing, we remain with r squared. Then this side, we worked out this to say if we multiply 21 9 times, it will give us the top, meaning 21 can go into the 189 number 9 times. From there, we noticed our progression. Our progression was in positive way. We know that after finding a square root of a number, we expect positive and negative. But in this case, we are going to get the positive value because our progression is in a positive way. So after finding this r, we can just go back here on this part and replace so we can see here there is a times r. We have found this r, so we can replace it so that we are able to find a. So allow me to write it from here. A times r was equal to 21, but I know that my r is equal to 3. So I'll come here and say a 3 equals 21. Then I'm looking for a, so I'll divide the 3 from both sides. Pardon, from both sides. This side it will cancel off, and then this side 3 into 21, it is 7. I'll conclude here to say therefore 7 is the first term and 3 is the common ratio. So that is the conclusion that I can give on the first question. Let's go to the second question and find the 60th term. Okay, so we are finding now the 60th term. So which is question number 2, 60th term, or we can just say T6. So remember from what I said, if the term is number 6, then you expect your r to have a power which is just below 6, and that is a 5. We have our data here. A is 7, r is 3. So we just come here to replace. Our a is 7 and our r is 3. Then 3 power 5. So 3 power 5 equals 3 times 3 times 3 times 3 times 3. 1, 2, 3, 4, 5. So 3 times 3, this is 9. 9 times 3, it's 27. 27 times 3, this is 81. And then 81 times 3 will give us 243. So that's what we have there. So we are going to have 7 times 243. Then we are multiplying 7 by 243. So we can just say 7 times 3, which is 21, we write 1, then carry 2. 7 times 4, it's a 28, plus 2, 29, 30. We write 0, carry a 3. Then 7 times 2, it's a 14, plus 3, 15, 16, 17. And that is how we are getting our answer here, which is T6. And then we can conclude to say, therefore, 7,701 is T6. So let's now go to the last question, which is saying sum of the first 5 terms of the progression. Okay, basically there are two formulae for the sum of the GP. So there is this formula. I'll explain how they differ. So this formula is used when your R is less than 1. Then there's this formula. So this formula is used when your R is greater than 1. So you have to be mindful which formula you have to go with. So make sure they just differ in the brackets and down here. If you can notice, this one is starting with 1 minus R power n, and down it is 1 minus R. If you can notice the other one, it's R power n minus 1 and R minus 1. So they are just different at that point of 1 or R beginning. So according to our data, we have got R equals 3. So of the two, we are going to go with where R is greater than 1, because this number is greater than 1. Hence, we are going to go with this formula. So I'll just erase, then rewrite the formula. So we are going with sum equals so this is the formula we're going to go with. Then we have our data. A equals 7, R equals 3. So then n depends with the number of terms you're finding for. So the sum of the first 5. So this word 5, this number 5 becomes your n. If they tell you sum of the first 10, it will be 10. Sum of the first 17, whatsoever number you're finding, that is going to be your n here. So we replace where there is n, we put a 5, then a is 7, open brackets, r power n. So r is 3, then power n, which is a 5, minus 1 over r, which is 3, minus 1. So at that point, this is paper 2, you can use a calculator, which is 243 from our previous calculation, then minus 1. So we have that, then over 2. So 243 minus 1, that is 242, then over 2. Then we have 7 times 2, it's a 14, carry 1. 7 times 4, it's a 28 plus 1, 29. Then 7